back. So what we have is the test review, and I'm going to go through it quite quickly, but most of these are repeats from quizzes if you were to look at the quizzes. First one, if a function is f, and then f of s plus t equals f of s plus f of t. All right, the answer is false. And the reason it's false, again, is we know that functions don't operate this way. And the easiest way to show that is to go back to one of our classic functions, f of x equals x squared. And I then just think to myself, let's pick s and t. I pick 2 and 3. And then the question becomes, does f of 2 plus f of 3, or does 4 plus 9 equal 2 plus 3 is 5, 5 squared is 25. Does the sum of 4 and 9 equal 25? The answer is no. So the first one is false. The second one, there's really not much to reason with, to talk about. A vertical line intersects the graph of a function at most once. That's true. If f and g are continuous functions, then f of g and g of f are the same. That is false. Number 4 is a limit property. If the limit as x approaches 5 of f of x equals 2 and the limit as x approaches 5 of g of x equals 0, then the limit as x approaches 5 of f of x over g of x does not exist. Remember, the limit law says the limit can go to each of these, but that's only if the bottom is not 0. And it is 0 this time, so that's true. It doesn't exist. You can't divide by 0. Number 5 was missed quite often. If p is a polynomial, then the limit as x approaches b of p of x equals pb. Okay, so p of x is obviously a function, okay? If it's a polynomial, it means it's continuous. And you notice here for problem 5, I graphed a red function, some polynomial. It's continuous, no jumps, no infinites, no removables. And then I put letter b on the x-axis, and I show the point where it's pb on the y. What I want you to catch here is that the left hand and the right hand limit have to be the same as the function because a polynomial is continuous. That is one of the big deals going forward. That is absolutely true. Number 6. If f and g are differentiable, then the sum of the derivative of the sum is f prime g prime. That is true. If f and g are differentiable, then the product fg is fg prime plus f prime g. It's a little backwards, but it's true because it's a sum. That takes us into what I would call the lightning round. You should be able to answer the following questions probably as fast as you can write them down. And if I just start going through it, the derivative of sine x is cosine x. And again, watching that it's not a chain rule property, it's x here right now. The derivative of tangent x is secant squared x. The derivative of secant x is secant x tangent x. Derivative of cosecant is negative cosecant x cotangent x. Derivative of cotangent is negative cosecant squared x. Finally, the derivative of cosine is negative sine x. Quotient rule, f prime g minus g prime f all over g squared. And finally, the derivative of c, where c is a constant. The derivative of 9, the derivative of 12, the derivative of 13. The derivative of c is 0. And again, we took notes on that. And that would be the lightning round, page 1. Moving on, page 2. Number 19 was missed quite often, mainly because we didn't know how to handle the radical portion. It says find f prime if f of x equals the square root of x to the 5th minus 4 over the 5th root of x. We're going to use the power rule for this. And again, the power rule is this. But to get to that point, we got to put these in fractional exponents first. The square root of x to the 5th is x to the 5 halves minus, and again, if I bring x, the bottom is x to the 5th, but when you bring it to the top, it's x to the negative 1/5. Now I just have to do the power rule on each term. So it's 5 halves, x, 5 halves minus 1 is 3 halves, minus 4 times negative 1/5 is positive 4/5 here. X, take away 1, negative 6/5. I would have taken the green. If you want to do it in blue, we could have done it as back to radicals. And I was fine with this answer too. Problem 20 had 4 limits, and again, these are all pretty much review problems. If I squeeze them in here. The first one I was looking for, did you really understand that you had to use the conjugate here? Because you can't plug 0 in. So I was looking first, did you make this jump? Multiply by the conjugate on top and bottom. And if I did that, my next step here was the limit as x approaches 0. Again, being really careful to recognize that this distributes, and we don't distribute the bottom. When I do that math, on top, you should have got positive x squared over x times 1 plus 1 minus x squared. You notice I have not plugged a value in yet. I was checking for that. I think that's where they cancel. And now if I plug 0 in, the top is 0 over 1 plus 1, 0 over 2. The answer to this problem was 0. On letter B, again, can't plug 2 in. You plug 2 into the denominator, it becomes 0. But then you do this, and look, oh, a very quick and easy problem. The answer was 5. Likewise, on C, you plug 4 in, and the bottom became 0. So you can't do it. Alright, so you factor. And again, they canceled 4 over that, so I get 4/5. And again, no notation like this. No notation like this. This is horrible notation. You have no function. That's bad. Alright? So let's not do it. Alright? On the last one, hey, it's polynomial. Just stick it in there, just like the true and false problem, number 5. I just had to put the value in there. So now I just go limit as x approaches 0. This is 0 minus 3. How about this equals negative 3? And again, a time sucker, an easy problem. Last few problems. Find the derivative of each function with respect to x. Kind of like problem 19, but here we want to probably set this up as x to the half first. Then take the derivative, y prime equals 1/2 x to the negative half, which I would have taken, or you could probably write it any number of ways if you wanted to go this route. Something you'll probably get used to seeing. On the next one, dy dx equals derivative of negative x squared is negative 2x, derivative of negative 2x is negative 2. 23. Again, these are all power rule problems so far. Y equals derivative of x is 1. So y prime equals 1. Then another straight up power rule on 24. We'll do dy dx this time equals, bring down the power, 4 times 5 is 20, reduce the power by 1, x to the 4th. That took us to the last 2 problems. Those 4 were just quick chain rules. On these problems, number 25 is a quotient, and number 26 is a product. So you have to be able to remember, and you had to put this on the front page, f prime g minus g prime f over g squared. Alright, and f in this case is obviously 4x cubed on top. G is 5x to the 5th plus 5. So f prime is 12x squared, and g prime is 25x to the 4th. Right, now you have to just do the algebra. And the algebra got thick. I'll give you that. The algebra got thick. So I start saying, all right, I'm going to write y prime equals f prime g minus g prime f all over g squared. Alright, now I gotta just clean it up a little bit, so I do some distributing. This gets a little long. So I'm going to get 60x to the 7th plus 60x squared minus 100x to the 7th. Oh, look, like terms. Likewise, on the bottom, I see there's a lot of 10s in the top, so I'm going to factor the 5 out. And let's make sure that we see that I still have that all squared. So now, I get some like terms, I combine them. I get negative 40x to the 7th plus 60x squared. All over. On the bottom, I can write that as 25 times x to the 5th plus 1 quantity squared, squaring both terms, or both factors here. Alright, so now, last step, let's simplify. And if I pull a 5 out of everything, because I can, my simplified answer is this. Now, to be clear, most of your credit would have been right here in this area. Out of the 20 points, I probably issued 19 points or 18 points of credit for that point. We should be able to take it down to this point. That's just algebra. All right. And that was problem 25. All right. On problem 26, y equals x squared cosine x. Writing 2x times negative sine x was minus 20. You can't do that. It's a product. This is not allowed. All right, so that was just minus 20 points. That said, you have to see that this is two functions, and you have to use the product rule. So I was looking that you understood this mentality. And again, if I'll define it this time, I'll define f is equal to x squared. I will define g as cosine x. F prime is 2x. I agree. G prime is negative sine x. So my derivative this time, y prime. And I would not write that stuff in black or red out. I always do it the same way. I look at x squared and say derivative of x squared is 2x. Leave the other thing, cosine x. Plus, now leave x squared and take the derivative of the other thing, which is derivative of cosine is negative sine x. Clean this up a little bit, and I get y prime equals 2x cosine x minus x squared sine x. And that was our test. Again, we won't spend any class time, so take your time and review the problems here. Practice as you need to practice. These are all pretty straightforward problems. We're going to start using this as our baseline for everything else we're doing.